So the first thing I'm going to start off with is a properly sized cluster. I mean, you'll hear a lot of people from Couchbase talking about a properly sized cluster. That's really where you need to start. Clusters, probably the most common thing that I see that people get wrong is sizing their clusters and keeping them sized correctly. If you do not get your cluster sized properly, then the rest of any other kind of knobs or switches that I might go over really don't matter. I mean, they're only going to be the last little bit of performance that you might get out of Couchbase. Most of what you're going to get out is going to be in sizing. So the things that I want to talk about is in this one is you really need around 3 times the resources of what your total data set is. You need to take into account the things, I mean, like replicas, compaction, use and index XDCR, but also the things that people forget about is maintenance. What happens when you're going to do maintenance? What happens when there's problems? If nodes go down or something like that, you need to size for those kinds of things as well. You need to make sure, like with your replication, your intracluster replication, that in the intracluster replication, that we try and keep all of that in RAM if we can. And some of that going to get ejected if we come underneath memory pressure. But we do try and keep that in memory, and we keep it on disk. So every time you put a replica in there, it's going to affect your performance. Compaction is another thing, another area that we'll look at where you have to take that into account. And again, the number of nodes. I mean, that's kind of common sense. But I mean, you need to make sure you have the right number of nodes, the right number of resources, and the data is spread across the number of nodes that you need for your cluster. So you got to size your I/O for your workload. And it sounds like common sense, but I see this all the time where people have not done this. I mean, if you have heavy writes and view queries, you need to kind of size. You need to lean towards SSDs. They're going to be fast. You're going to have your queries. I mean the disk queues when we push things down to persist things down to disk. You need to make sure that's going to be as fast as possible, especially if you're using things like persist2 in your data for the transactions that matter to go down to disk. That really you want to have those queues as small as possible, and SSDs are going to help with that. And when it comes to views, since they are, for today, coming off disk, then that really needs to be off SSDs. If you're on 2.5 or below, then when it comes to view changes and XDCR, then SSDs are going to matter as well for the performance of those. Even if you're heavy reads and a stable workload, then maybe spinning disks are going to be fine for you. It really kind of depends. Most places I see end up with spinning disks and only go to SSDs once they really matter. If you're working with someone like myself, at Couchbase in sort of the pre-sales environment, I can actually help you look at what you're doing and size some of that. And a lot of the information also is online to sort of piece through that if you run like on the community edition. So consistent high performance is going to be the most important part of this. You have to keep that going. You have to keep so that your lines of operations, the ops per second, is just sort of bubbling down just at a nice level. And doing that part of the I/O is going to push that. And again, as I said before, I mean, ensuring overhead for maintenance tasks. When you're going to do upgrades, you can do where you pull a whole node out. Are you sized? Did you start out sized and you can stay sized so that you can actually do those kind of upgrades? Just an example. My mom calls me this morning and says to me, "Well, I need to upgrade my iPhone to 8.02, but I don't have enough space on my iPhone to download the update to do it." So when it comes to clusters, I have the same sort of conversation with people where they need to update, but they can't pull a node out of their cluster in order to actually upgrade to Couchbase or upgrade them, do the maintenance. So you have to make sure that you size for that. And another big one is, since we do like to keep everything in memory, is RAM sizing. And that's probably going to be one of the things that everyone, of course, thinks of is for Couchbase. So we like to keep things in RAM. So it is important, obviously, for the reasons that I state here, but it's not the only place, as we've seen, as I've been talking about. So disk considerations, I've talk a little bit of this about, and so spinning disks, like I said, most times that's going to be just about fine for things. SSDs, and in extreme cases, I put Fusion IO on here. We're also working now with some of the other SSD vendors, SanDisk, Aperion, and a couple other ones to talk to how to make sure we can keep those disk queues down and keep the low latency on disk. Those things start to get pricey. So those are sort of at the extreme end of performance of what you might need, and if your use case fits that, then that's definitely an option, and we'll perform on that. And also coming up with my understanding with the Forest DB that was announced yesterday, that's going to be even more optimized for running on that kind of hardware. And the other big question I get is how many cores that people think they should run on. Sort of it matters to a point depending on what you're doing. You'll hear that a lot of people at Couchbase, well, it depends for lots of things, and cores is one of those. We like to start out with about 4 cores minimum, and then if you add more buckets, then you usually need about a core more for that, for each one of them, and then more cores for each design document and views that you're going into that. XDCR, well, I hear different things from different people. I usually like to say 1 to 2 more cores per stream. It really depends on a lot of your write load and what you're doing and how many updates you're pushing across XDCR as what you, and these are sort of, I mean, again, rule of thumb, much like anything else with performance and sizing is with that. So bandwidth. When it comes to this, I mean, there's lots of things where bandwidth comes in. It's obvious everyone thinks of bandwidth for coming into the front end and getting your data and CRUD operations. But a lot of people don't think about rebalances and how much performance rebalances take. I mean, rebalance is supposed to be a background operation, and a lot of people think, oh, my rebalances are really slow. And there are times where it's kind of by design for them to be a little bit slower. We'll talk a little bit later about how to maybe increase the performance of those, so you can sort of, there's some background settings that we can do to sort of sacrifice a little bit of the front end performance to make rebalances go faster. But it's something you need to size for. Make sure that you have enough space. Again, getting back to sort of maintenance to be able to do that. So the intracluster replication, I mean, we're pushing data in between clusters. By default, you adding replicas makes it so that you're going to be using more network bandwidth to be able to do that. Same with XDCR. If you're going to be pushing a lot more data across there, if you're going to be doing multiple locations, then you're going to have to size for how much data you're pushing out. What's the authoritative source? Are you using a hub and spoke for XDCR? Are you using